Welcome back. It's always a happy day to see you again watching these videos. And in this lecture, I'm gonna go through halogenation. And if you remember, the first reaction that we went through it was hydrohalogenation. The second was acid catalyzed hydration. And this video, we're gonna go through just halogenation. That means the condition we use must be non-technical, non-protic or a protic, a protic solvent, a solvent that's not capable of donating H. So I go with a protic solvent or non-polar. And one of this solvent, it can be, for example, CCl4 carbon tetrachloride. Is completely non-polar and it doesn't have acidic hydrogen. Okay, and okay, let's go after this reaction. Okay, a reaction is going to happen between an alkene and chloride or bromide. Okay, and we have, for example, okay, let's say we have bromide, and bromide is attached to another bromide, and each bromide, it has 3 lone pair. Okay, and so let's assume one of this is a central atom. It means this is going to pull, and for short term, we're going to have a positive charge here, and this one, for example, negative charge, okay, for short time. Okay, and so I have a double bond, and this double bond is going to behave as a nucleophile, and a double bond, it will go after one of the bromide. Okay. And what do I get? I get bromide somewhere here. So this is going to be a bromide attached to 2 carbons. Okay, and a bromide, it will have a positive charge. Remember, each of this carbon, it has hydrogen. Now, the bromide that is attached from the top of the ring, hydrogens, they go down. So I'm going to put the hydrogen down there. Okay. Or I can add the bromide from the bottom of the molecule. So if I add bromide down here, that means hydrogens will be this position. Okay, maybe I need to move this one down there. Okay. That's going to be hydrogen. Oh, forgive me. Okay, those 2 are hydrogens. Now, bromide, again, it has a positive charge. That means we're going to have a ring. And where is that ring? This is the ring that I'm talking about it. That ring is made of 2 carbons and 1 bromine, and there is a positive charge there. So it means this carbon, those 2 carbon, also they have some positive charge, because the positive charge is not going to be absolutely just located on bromide. Okay. Now, next, what will happen with the second, bromine atom? The second bromine atom, we have. Okay, we have a bromide here. Bromide, it has 4 lone pairs. So that means it has a negative charge. Okay, and that bromide, it can attack. Okay, it can attack this carbon. Okay, it can attack either that carbon or that carbon. In this case, they are the same, like they have exactly the same group, same substituent. So it doesn't matter which one we attack. Okay, but keep it in your mind. Addition, it cannot happen from the top here. Why? Because the top is already taken by bromide. So if you want to add the bromide to it, bromide has to reach it from the bottom of the molecule. So I'm going to show it by an arrow. Okay, bromide. Okay, next step, bromide, it will attack either that carbon or that one, but it has to be from the bottom of the molecule. Okay, so it has to attach it and reach it from the bottom. Okay, and how about this? In this case, it will reach it from the top. Again, we can attack both carbon. It doesn't matter which carbon you go after it. So I can draw this one also that way. Okay, and Now let's add next bromide. Okay, so this bromide is going to behave as a nucleophile. This is going to be our nucleophile, and we will add the nucleophile to the intermediate. Okay, and the nucleophile, it will be added from the untied position. Okay, what does it mean? It means the addition, it will happen from bottom of the molecule, wherever you have the intermediate, wherever you have the bromonium ion, or this technically this bromine that's made a ring. And if it's sitting at the top, then the bromide or the nucleophile, it will reach it from the bottom. Or if then like the bromonium is on the bottom of the molecule, then the bromide, it will reach it from the top. Okay, so here I have two carbons. This is going to be carbon number 1, and that's carbon number 2. If the addition happen, okay, to like forgive me, if the bromide attack carbon number 1, if attack carbon number 1, I'm gonna have bromide at the bottom. Which bromide? The new one that we are adding. I'm showing it with blue color. Now, what will happen to hydrogen? Hydrogen is going to go up. Why? Because we added, okay, we added the nucleophile to the bottom of the molecule. And now, what will happen to this hydrogen? This hydrogen is going to show up on the second carbon, okay? So that bromide, it will be on the top of the ring, technically. And we will have the bromide up. So in this case, bromide, it will be up. And I'm going to say this is original one. And what will happen with the hydrogen? Hydrogen, it will stay down here. This is going to be hydrogen. Okay, now let's assign to configuration for it. And configuration, this is going to be number 1. That's number is going to be number 2, and this one is number 3. Where is hydrogen in the back? So this is going to be our configuration. Okay, how about this one? Okay, this is going to be 1. Here is going to be 2, and that one it will be 3. So this is going to be supposed to be S, but because we have hydrogen facing to us, that one it will be R. Okay, so I got R and R. Okay, I got R and R. And if we add, okay, now if we tag, for example, carbon number 2 first. Okay, so we are going to go after carbon number 2. Okay, if we attack carbon number 2, then bromide, okay, it will be here. This is going to be the new nucleophile that was added to the system. And what will happen with the original bromide? Original bromide, it will show up on carbon number 1. Okay. So bromide will be here. And of course, I'm going to have hydrogen. One hydrogen is here. And next hydrogen, it will be there. That's going to be hydrogen. Okay. So, you know, we have a bromide that is sitting on the top of the molecule. Okay, we have to reach the system from the bottom. Okay, so we technically our nucleophile, okay, our nucleophile, which is this, reach, okay, reach this carbon from the bottom, or that one reach carbon number 1 from the bottom. Okay. And again, what do I get here? I get, let's assign the configuration. I go 1, this is going to be 1, this is going to be 2, and that one 3. So this is going to be S, okay? And next one, I go 1, here we have 2, and that one will be 3. So I go 1, 2, this is R, and because hydrogen is facing to us, is the 4th priority. So this is going to be S. Okay, now what's the relationship between these two? The first molecule and the second molecule. Okay, and let me erase those numbers just to make it more, you know, clean. Okay, so those numbers are gone. Okay, now So the top one, it says RR. The second one is SS. So I'm going to say these two are enantiomer. Okay. These two are enantiomers. Okay. And again, we don't have a mirror here or inversion center. So each one optically it will be active, but we're going to get 50% from each one. Okay. 50% from each one. So the mixture optically, it will not be active because we have 50-50 from each one. Okay. But the relationship between them, it will be enantiomer. Okay. Enantiomeric technique.